Hey, what's up everyone? My name is Ryan and welcome to Math with RG. Thank you so much for checking out this lesson today. Remember, it's going to be you and I, and we're going to conquer this. Are you ready? Here we go! Hey, what's up everyone? We're back. I'm Ryan, and today we're going to talk about distance equals rate times time. D equals RT. This is one of the classic formulas in math to figure out your distance or your rate or your time. This is a very important formula because it can help you figure out all kinds of things like driving in a car or riding a bike or walking, skateboarding, whatever it is, whatever vehicle you're using, whatever mode of transportation you are using, you can figure this out, right? If you're on a train or a plane, whatever it is, this equation will help you out. Distance equals rate times time. So let's bring down the equation first and just take a look at it. Distance equals rate times time. Now, right now it's just a bunch of variables. It's D equals RT. I've heard some people abbreviate it as DIRT, right? I don't know why, because it's really not dirt. It's a great, great formula. So let's check it out. D equals RT. Now, when letters are written next to each other, that means multiplication. So the variables R and T, rate and time, are written next to each other, so that means multiplication. Okay, so I just want to do a little bit of manipulation with this formula just to show you the other ways to write it. So D equals RT. Now you could solve for R, and then that would equal R equals, well, what would we do? Well, we would have to divide by T on both sides to get rid of the T and get the R by itself. So it would be R equals, or rate equals, distance over time. Okay, now let's also isolate the other variable. So let's say we wanted to isolate the last one, which would be time. So we would have to divide by R on both sides because it's rate times time. And so we divide by R on both sides and we would get distance over rate. Okay, so distance equals rate times time, rate equals distance divided by time, and time equals distance divided by rate. Okay, now that we have that squared away, I'm actually going to remove these two right now because we don't need them. And we're going to talk about this example problem. So let's talk about this example problem that I made for you. I mean, I wrote it out. I didn't create it. Somebody else created it. Okay, so here we go. Let's say you are riding uphill to the grocery store at 20 miles per hour, and it takes you 18 minutes to get there. And then you get your groceries, you turn around, you come back down that same hill from the grocery store to your house, but this time you're going 60 miles per hour down the hill. Now, I don't know what you're riding, if it's a car or a bike or whatever it is, but please be safe out there, especially on those scooters, you know what I'm saying? Okay, so again, you're riding up a hill for 20 miles per hour for 18 minutes to the grocery store. And then you're riding back down the hill at 60 miles per hour. Now, it's the same path, which means you have gone the same distance on the way up as you did on the way down. Home to the grocery store to home. So the question is this, right here. What is your average speed for the entire trip? Average speed for the entire trip. Now, speed is another way that we can say rate, okay? So we're going to focus right here on this equation, distance equals rate times time. We're going to break down each thing, and then you'll see how we solve this. So here we go. So we have 20 miles per hour, 18 minutes. Well, 20 miles per hour is our rate for going uphill. 18 minutes is our time that it took. So what are we missing? We're missing the distance, right? But here's the thing also, the units have to be the same. We have 20 miles per hour and we have 18 minutes. So what we need to do is take that 18 minutes and we need to turn it into hours. Well, how many minutes are in 1 hour? That's 60. So we do 18 over 60. And we're going to reduce that fraction. So what is the greatest number that goes into 18 and 60? And let's think about that for a moment. 18 and 60. Oh, and by the way, here's a hint. If you don't know the greatest number right away, then you can just divide it by 2 because they're both even, and then divide by 2 again. And if they're both even, then you can divide by 2 again. But the greatest number that goes into 18 and 60, well, that would be 6. So we divide each one by 6. 18 divided by 6, that would be 3. And 60 divided by 6, that would be 10. So this is now 3/10 of an hour. Okay, so now we plug it into our equation. So I'm just going to move this up a little bit. Well, actually, no, I got space over here. So we have distance equals rate times time, right? This equation right here. So the distance is the thing we're missing. So distance equals rate, we know, is 20 miles per hour, times our time, which is 3/10 of an hour. And now we solve that. Distance equals, well, I can do two things. I could do 20 times 3 and then divide that answer by 10. Or I could cross cancel. And so I could go, okay, well, 20 over 10 simplifies to 2 over 1. So now it's just 2 times 3 divided by 1, which nothing happens. So 2 times 3 is just 6. So we have 6 miles. Okay, so now I know that the distance is 6 miles, right? And that's going this way, or 6 miles going this way. Okay, so now I need to go down to the last part where it says we went down the hill at 60 miles per hour and we went for a distance of 6 miles. So again, I bust out my trusty formula here. Distance equals rate times time. I know that my distance was the 6 miles and my rate was 60 miles per hour, and the time is the thing that I don't know. Okay, so now I'm going to solve. Well, in algebra, we have to divide each side by the same thing in order to isolate the variable if you are multiplying the variable against another number. So as you can see right here, we have 60 times t. So what I'm going to do is I'm going to divide by 60 on both sides so that I can get the variable t alone. 60 divided by 60 is 1. And then 6 over 60, I'm going to reduce that fraction. The biggest number that goes into 6 and 60 is 6. So 6 divided by 6 is 1. And 60 divided by 6 is 10. 1/10 of an hour equals the time. Okay, so now we're almost to the end. So again, we bust out our trusty formula here. We've got distance equals rate times time. Well, remember the question up here, they want the entire trip, average speed of the entire trip. So, what is your average speed for the entire trip? All right, so here's what we have to do. We have to take our distance, which is 6 miles one way and 6 miles the other way. So the total distance, right, let's write that down, total distance is 6 plus 6, which equals 12 miles. And then we have to do our total time, which was the 1/10 of an hour right here, and the 3/10 of an hour, right? Because it took us 3/10 of an hour to go up the hill, and then just 1/10 of an hour to go down the hill. Okay, so here's what we're gonna do. We are going to take the 1/10 of an hour plus the 3/10 of an hour, and we're lucky they have the same denominator, so we don't have to find the same denominator because we're adding fractions, because we're already in luck. They're already the same denominator. So that is 4/10 of an hour, and there's our total time. Okay, so now we're going to plug it into our formula. Here we go. Total distance, 12, equals the rate, which we don't know, because that's the thing we're looking for, our average speed for the entire trip, times our total time, which is 4/10 of an hour. Okay, now here's the question. How do you get rate by itself when you're multiplying by a fraction? Well, the trick is this. You want to multiply by the reciprocal on both sides. So actually what I'm going to do is I'm going to write this equation again so you can see what happens. We have 12 equals R times 4/10. I'm now going to multiply by 10/4 on both sides. And that is the trick to getting rid of a fraction. You multiply by its reciprocal, and you do it on both sides to balance it out. Okay, so the 10s cancel out, the 4s cancel out, so that's just 1. And then over here we have 12 divided by 4. So that becomes 3, and that becomes a 1. And now we have 3 times 10, and that is 30. Miles per hour equals rate for entire trip. And there you have it, everyone. A wonderful example of distance equals rate times time. Thank you all so much for watching this lesson today. This has been Math with RG. I'm Ryan, and I will see you on the next video. Bye-bye.